Okay, welcome to this, our third lesson, introducing you to AutoCAD and structural drafting for civil engineers. But as I said, this can apply to many professions or architecture or whatever. But here we go. We're going to learn more about further drawing tools and also steelwork layouts today. We're going to be following on from the first two lessons. Lesson 1, where we were introduced to AutoCAD and general interfaces. The second lesson, where we started learning about buildings, sheeting lines, setting out buildings, and the basic drawing tools. What we're going to get into now is completing the building details we did in lesson 2. We're going to start learning more about steelwork layouts. We're going to do some hatching, setting up blocks, scaling, fillet and chamfering, layers, and the likes. So let's get going. Let's swap across to AutoCAD here and get going. Alright, so that's where we got to in the second lesson. Now we're going to continue with this, but I think it's just going to be faster to continue with it down here. We now need to add some hatching to this. Hatching is the sort of fill, this colouring in that you do. I'm going to delete the hatching we've got there already. If we want to fill up those areas with the hatching to show what it is, we've got a hatching tool here. There we go. Hatch. The hatching can be used for different ways. See, that's concrete, brickwork, elevation showing sheeting, you can use that hatch. Earthworks or just soil, you can use that. You can use elevation on brickwork when it's not a section through it, you can use a hatch like that. So there are various ones that you can use to get different effects. But we're going to add now some concrete and some brickwork hatch. So we're going to click hatch, and then this new ribbon pops up. Let's find the hatch we want. There's various ones you can take here, and you can use them for different things. There's our concrete one. We're going to click where we want to put the concrete there, and there. We now need to get a scale that works for us. Let's try 2.5. And there we go. We'll just click it in the wrong area. And yeah. Okay, we've got a hatch showing concrete. So at least the drawing, it's more clear that that is concrete. Let's add another hatch to add for the brickwork. So there's our hatch tool. Click. We're going to now select the brickwork, the section brickwork down here. Some versions of AutoCAD don't have this layer, so just see what's closest for what you've got. There you go. Let's try a different scale. Yeah, maybe a bit more. 25. You can just play with your hatching scale so it looks right. Angle correct. Okay. And there we go. Press enter and it's done. Just make sure it's on the right layer. So there we go, because if I go back to home, you can see, yes, that's on hatch. It's useful having the layers on hatch, and you can control them, turn them on, turn them off again. Alright, if I want to add some hatch at the bottom here, let's say I want to show that this is just earth below. One of the common ways that we show earth is you just draw a polyline and you fill it in, so it becomes an uneven thing like that. So you have that sort of effect as you're looking there. And now, so what I'm going to do is just draw a polyline, and then I'm going to put it on a hidden layer so that it won't plot. So let's start here, and I'm just going to turn off ortho. So press F8 to turn off ortho, and just sort of click around. And there we go. Now, if I hatch that in, go to my hatch tool once again. Let me find the earthworks layer. Go. Click where we want it, click where we want it. We normally use this at about a 45-degree angle. Let's increase the scale, maybe 50. Alright, great, there you go. If you've got layer works below, you otherwise should show the layer works. Normally you would have concrete and then cement stabilized layer works and gravels and such below, but for now we're just going to show it like that. Either I could delete this layer line like I've just done, or if you think you might need to edit it later, you can change it and put it on a hidden layer. So I go through, and do I have a layer? No. What I can do is create a layer. Now I'm going to go into my layer properties. I'm going to click new layer there and go hidden, hidden, hidden. Sometimes what's useful is you make it on a color that you don't normally use, so at least you can tell it's not an ordinary line you're playing with. If you see it, that probably shouldn't be there. You go hidden, There you go, change it to hidden. Then there's multiple ways now we can turn it off. If I go back into my layer properties section there, either if I scroll up to hidden, I can just turn it off like this. So it freezes it, it turns it off. Or there's another way, so this light bulb. So on, you can turn the layer, turn it on, off. You can freeze it. It's normally better I just freeze it. Freezing, then it doesn't move. And then, or what you do is you can turn around and you just set it to not print. That's another way. So even if the layer is on and you can see it, when it comes out, it won't come out the plotter when you plot it or print it or PDF it. So, alright, so that's the way. We've got it, I've turned it off, and I have hidden it. We'll come back and play with those layers just now. They're very useful. Alright, we now have our building. We've got a layout done. We've got dimensions. We've got labels. We've got all sorts of things. We've hatched the concrete. We've hatched the brickwork. Let's now start on a roof layout. Let's start creating a drawing like shown here in this box. And let's see if we can produce one of those layouts. So what I'm going to do now is get the column sizes. So we're now going to do basically a plan view. If you look at it, you can see all that information that we're looking at right now, but with labels and with everything else. So let's minimize that, go back to our layout. I first need the columns. I'm going to add some columns on all my grid lines. And from this layout, you can normally, when you draw up, get a feel for what size member you're going to use. As we discussed earlier, we've got a 305, 102, 29 column here. So I'm going to use that column on these grids from there to there on the edge. And on the edge, I'm going to use an IPAA 200. Some of those sizes came out from detailed design. But often during preliminary design or when you're doing preliminary layouts, you can get a feel for what size and put in close enough sizes. Okay, let's just cycle through my drawing. Alright, what we're going to do now, I'm going to take two sizes, the correct size here, and also let's say there was a size I used during preliminary sizing. Let's say this 254, 146, 37. Let me take those two and press Control C and cycle back to our drawing, Control V. Here are our two columns. Imagine now I take that column during preliminary design and I put it on all the layouts. We start generating more layouts and columns and foundations, and then you find that the column size is wrong. You don't want to go back and have to change all the drawings you've done. So what a useful way to do is to create what's called a block. A block is a sort of a fixed group of AutoCAD lines and drawings. But what happens with a block, you create one block and then use it multiple times. And if you update one block, it updates all the rest of the blocks. So what I'm going to do now, I'm going to turn this. This is already a block on its own. So if you have a look at it, I'd have to explode it. Use this to explode it. Now it becomes a group of lines. But currently it's saved as it is a block, but I'm going to put this block inside another block. Sounds confusing, don't worry, you'll see why now. So if I go to Insert, Create Block, and then I'm going to call this column Main. So this will be my main column, and I can repeat it multiple times. And then you can even specify the base point and where you insert it. There's various functions you can use, descriptions, especially if you're using a block many times. It's useful. You set it up, and then you can keep plugging it into your buildings again and again and again. All right, so that's my main column. I've already done this, so I'm just going to don't redefine. I'm just going to give it a new name. End columns. This is from earlier. I set it up for testing this drawing, so I've set up now. So I'm now going to move this column in place. So it's going to start, my gable ends, that gable and that gable is going to be a different size, but on my main ones I'm going to use this size, and I'm just going to move it into place. If you don't have a line, so you've got a nice cross to move it onto, you just draw a line across, select this, move, enter, enter, and then move, where's my center line, there we go, onto that point. Alright, it is now centered over the grid line. Let's now create an array. So I'm going to select it, go to Array, click Array, And then I've got 8 of these, so I'm going to go count, C-O-U, count, is 8 columns, 2 rows, spacing, S, enter, so it's going to be minus 7,000 between my columns, minus 15,000 between my rows, and there we go. There we have a layout. If you can see now, it's all together. And click on that, yep. And we can now start adding more stuff. Let's start adding these roof trusses to our drawing. So what we're going to do now is add a, if you remember this chords, it's 1996 or 1965-6. So the chords are about 90 mils wide. That would be these angles top and bottom. They're about 90 millimeters wide. So what we're going to do now is add in some that are 90 mils wide. Sometimes the trusses, the angle is actually the center is not on the center of the line, but it just depends on the angle and layouts and column sizes and such. What I'm going to do is just offset this grid line, offset it by 45 mils each way. Now I've got something to make sure it's exactly 90 mils. I'm going to draw a square, rectangle, all the way from one side to another. This is now my truss. I'm going to move it 35 mils down. So if I click on that tag and I type in 35, it moves it exactly 35 mils. Let's do it the other side so you can see what I did there. Click on the rectangle. You've got that that vertex there. Click on it. Start moving in the direction you want. Type in 35 and it moves it. There we go. I'm going to delete my construction lines. Alright, and we've got a truss. And we can add multiple of these trusses. As we said, we could create an array or create a block with this truss in the array. What we'll do is once we've added a few things, then we'll start adding we'll create it in a block, and then we'll use that block for all of these layouts. Now we're going to add the outline of the building. We're going to add this outline here, the sheeting line. So to do that, I just need to make sure I can draw a square. I'm going to have a nice intersection there to draw to. It's going to be the same here. Now I've got an intersection I can snap to. Select rectangle. Start from there, go all the way out. You'll see in a minute why I'm doing that. Oops, you can see I've slightly clicked out. If you do that, either you just delete it or redraw it, or you can move this across. It's just going to be simple to delete this and redraw it. Select, delete, create another one. You've got to be quite careful, especially when you're trying to draw accurately, that sometimes you can have things snapping to the wrong point. There we go. Now I'm going to offset this and create this as a sheeting line all the way around the outside. So I know that's what I'm going to draw up until. So it's a sheeting line of 370 mils. I'm going to offset it there, 370 mils. Yep, delete the original. So that's going to be sort of perimeter, the edge of my building. I'm going to change that onto sheeting. I've got a sheeting line, and I'm just going to adjust the scale of the line type. 50. There we go. So that is now the perimeter of my building. So if you see on this layout I've already done, it goes all the way around, and all your girts go to that. That is the edge of the building. If we come back here, that is where the steelwork all stops. You can see that line where that yellow line is. We'll learn about that false rafter just now. And it's the same thing on this line. It's where that steelwork stops. The purple steelwork there, that's what I've just drawn. So we know what to draw to. Alright, because what I'm going to do now is I'm going to draw in the purlins. So those cyan lines over the top. Then I'm going to draw the knee braces, those knee braces. Then once the knee braces and the truss have been done, I'm going to add a label to it and create a block and then copy all the way along. So we've got one block for all the trusses, so it's very easy to edit. So let's now draw in all the purlins. So the easiest way to, since we've already done a layout with the purlins, let's use that layout. So let's select it, Control C, copy. Now I want to paste it as a block. Another way to paste a block, you press Control Shift V. So Control Shift V creates a block. And then now I've got this block here, so I'm going to rotate it. click 90 degrees. And I need now 3 to line up with 3, so it doesn't, so I'm going to click that. Go mirror, click create a mirror line. Array source object, yes, I don't want it anymore. And if I want to just put it a bit to the side, create a construction line off, and then I can line up, move grid line 3 with it. Now what I'm going to do is actually use this line I've just created and move it. And we're going to draw all our purlins using these construction lines. So I'm going to draw a whole bunch of lines from top to bottom, and then we're going to just trim them to suit. So I'll copy that line, and I'm going to put it at the front of each of these. Copy all the way down. You could otherwise do this with array. I'm just going to quickly do it this way, all the way down. And this applies, you can use this sort of projecting tool for many different things. You often, once you've done one layout, you put it next to another and then project from it to create all the rest of your drawings. Alright, now that I've got all those in, I'm going to click on trim, click on the edge of that, so that's going to be my trim line, press enter, select all of those, and it's trimmed it. Alright, so now we have all our purlins in place. So now what I want to do is match properties. So I go to our match properties tool there, and I'm going to click on one of these because I've already got it set up. It's on the right layer. Click there. Click on all of these. Alright, now we've got the purlins done. Now we're going to add our knee braces. Knee braces, as we were discussing in the last lesson, they're these little V's that keep our truss stable. Let's zoom in on one here. There we go. There's one of the knee braces that actually stabilizes the truss. It reduces the effective length. The knee braces can be used to support the purlins, but then you put one on every purlin. You must actually design it as part of the system then. This is just sized by slenderness and at the moment. Alright, so let's go. And we're starting from the second knee brace. So I'm going to just draw a line. Now I'll enter. And so let me just double check that. So yeah, so actually, sorry, it's from my first purlin. We've got one there. So draw that. Turn off auto. Press F8. Put it up to there. I'm just going to mirror this so it is symmetrical. Mirror. Create a mirror line there. Yep. Yeah, that looks about right. Copy. CO on, you can click on copy up there, specify a base point somewhere here, and if I've got ortho on, I can actually just copy from one line to another, all the way up, and up, and up. Right, now there's one, so match properties, there was this one I missed, didn't match its properties earlier, there we go. Now what I'm going to do is turn this whole truss and these knee braces into a block. First let me add in a piece of text. Let's say now I've only done this layout, so I copy that piece of text, CO copy, or Control C, Control V, up here. This was from a 1 in 50 scale, but now I'm drawing on a 1 in 100 scale there. For a plan view, it's normally 1 in 100. For a section, you're normally 1 in 50, 1 in 100, depending on the size of the building. What I want to do now is convert a 1 in 50 scale to a 1 in 100 scale. So this is half the size it should be. So I select it. Then I can scale it. So I click on Scale, specify a base point, at the bottom is Scale, specify base point, click here, specify scale factor, so or copy reference, etc. So I'm going to type 2 as my factor. There we go. And there is my text now. I'm going to edit that to say Truss 1, Truss 1. Move M, enter, move this across. And then I'm going to rotate this, click rotate, type 90 degrees, alright. And here is Truss 1. So I'm going to select all of Truss 1, all of Truss 1. There we go, and that, and that. Now I'm going to create a block once again. So we're going to insert, create block, Truss 1. Okay, now we've created our block. And we can copy him all the way along. There, and to all these different bays. We've created all of those. Now we need to do the gable face. I'm not going to run through that whole exercise again. You can see I've really got a block set up here with my gable. So I'm just going to copy that one. Copy all the way up from here to here. And I'll put another one this side. There we go. So those are all my gables done. Now, remember earlier I was saying what happens if we put the wrong size column in. Let's say now we've done a preliminary layout. We've created these blocks. We've drawn it all in, but we realize the column is the wrong size. Now we've got a 254146 here, but we actually need to use a 305102. So what I'm going to do, just going to move this close by so you can see these are two different sizes and I need to adjust to suit. So what I'm going to do is I'm first going to copy this one, Control C, there we go. Now I'm going to go into this block. I double click on it. There we go. So I think I must have not done that 100% correctly. Oops, I've lost my block for some reason. Oops. Alright, not serious. I'll do this on this layout. I'm just going to show you. It has not been created. Oh, sorry, I'm being foolish here. It's because it's still array. I'm trying to edit an array, and that's why it's not allowing me to edit it. So if I go to explode it, now if I click on it, there we go. It's now not part of the array. So if I double click into that block, there we go. Column, end column, open it up. So what I can do now is create this new block here. When you go into a block, if you double click on a block, it activates the block editor. You go into this window and you can start playing with this block, and if you edit one block, it'll change all instances of that block. What I want to do though is make sure this new column's in the exact same position as the old one. So I'm clicking the center line, moving there, move it across to there. Alright, I'm going to delete my original block. That. Right, done. I've changed the column size. If I go close, save, yes, are you sure you want to save? Now you'll see all the columns have been updated. I only edited one, but they have now all been changed. This is a very useful feature of AutoCAD that you can repeat your work many times. Right, so that column is now correct. So get that one out the way. Let's start finishing this off. I've got purlins, girts, etc. I'm going to add in some knee braces now, and some sag angles. There are these sag angles there. Those sag angles look something like that. Use the sag angles to stabilize your purlins. They bolt from one purlin to another. The one nice detail you can do is rather than having individual pieces from one purlin to another, you actually put a long piece below the purlin with T's up. It's much easier for the fabricator to make because you don't have to have a lot of little purlins. You have one with T pieces, so it's sometimes also quicker to erect, but it just depends on the fabricator. So we're going to draw all these now. They, as I said, prevent the purlins from buckling or the girts from buckling. And also this diagonal prevents it from sagging when it hangs, especially on the girts. On these, if you don't have these diagonals, you can actually see on site, especially on the longer bays, how your girts sag. And then when they do the sheeting, it looks terrible. So you put those in, at least everything is nice and straight then. So let's go back. I'm going to add now all these sag angles. So this first bay is probably a bit narrow to fit the diagonals. So I'm going to put in the second bay. And what I first need though is I need a center point to draw to. So I'm going to draw a line from one side to the other. So I've got a center point. There we go. Escape. Line. Draw. 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 There we go. And we can draw this up from the top there. And all the way down to there. Escape. And we can put this on our layer. Let's have a look if I've got a layer for that. Yep, steel sags. Well, I wanted it slightly dashed, so let's play with my scale a bit. Too much, I mean too little. Let's make it 100. Yep, that looks about right. We can play with that a bit more if you want to. 150. Great. Okay, we've got a bunch of sag angles in now. If you want, we could do the same thing of creating a block with this, or we can create an array. Create an array. Okay, let's go through that again. Count. So 10 of these, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 of them. So we need array. Sorry, COU count. Enter number of columns 9. Number of rows 1. Spacing S. Enter. Space minus 7,000. Enter. And enter. And there we go. Sag angles done. So that's almost there. Now we're going to add in some bracing. You can put it in looking like that. You just pick a slightly thicker line, and then you draw it in. Also, you can draw in these circular hollow sections. They provide sort of stability to the structure along with the bracing. So if we go to our model, there we go, that's our bracing, our roof bracing there. And our vertical bracing on the side, vertical bracing on the other side. So if the wind blows from this side and it blows on this face, the load goes from those girts to that column, up the column to the top, and down the bottom to the concrete resistance. At the top, the load will go down this pipe, this compression member, to the tension angles, and it is braced out. So we've created a little brace structure, so at least he is supported, that column, and that is supported then down these braces to the side, and the same on the other side. Oops, there we go. So this load will go up this column and then down. We couldn't put a brace bay in this end because of this platform, so we had to move the brace bay one back. So we added an extra pipe, an extra circular hollow section, just to carry the load down into the next bay where we could put a vertical brace and a vertical brace. Right, so let's draw those. So we can just put it on a slightly thicker line. But for now, I'm just going to be lazy and copy that over. If you've drawn one out, there we go. You put it in place there. There we go. And then if I'm going to add, say, a polyline with PL enter, polyline, and then I'm going to draw that from there to there to there. And if I mirror it across, MI enter, mirror, specify my mirror line, enter. There we go. Select that, check on steel bracing, there we go, steel bracing. Alright, now steel bracing is in. So now you can see our drawing is starting to take shape. It's starting to grow and look like something and give details. What we need to do now is go add labels. So go through and label that this is the gable raft is such and such size, this is the circular hollow sections, these are the trusses, and these are the sag angles, give them the size of sag angles, give them the size of knee braces, all that sort of thing. The false rafter here, just finding if there's your false rafter, what you use that for is for your sheeting. It's a little angle, you bolt to the bottom of your steel, there you go, you bolt that to the bottom of your purlins, and it slopes down with the roof, and at least it gives you something when the sheeting sticks up, it can actually fix to something at the top. So that is very useful. On the side, sometimes you just make sure your girt is high enough that it can pick up the sheeting. Or what you have to do, you can even get inventive and put something on the gutter, but just be very careful if you're fixing sheeting to gutters. Yeah, so there are various ways, but you just always have to make sure you've considered the sheeting and where you fix it and how you fix it and will it leak and all those sorts of issues. But let's go back to this. Now we can start adding section marks to our drawing. Let's say I haven't got anything yet. I go here, this is a 1 in 100 drawing, so I can select that. Copy, enter, move it up here. Because we created that section earlier, section EE. So it's grid line 3 on the left, grid line 1 on the right. So grid line 3 on the left, grid line 1 on the right. So it means we're looking from left to right. So let's rotate this, rotate. And it's 90 degrees. So that is the way we are looking. We are looking in that direction. We can move that around. Actually, we'll put one the other side first. Move. So we know where that section is taken. Move. And we can do that. Then we need to label this. Some of these are set up that as you open it, actually gives you a little command prompt. So value is now section E, and drawing, let's say it's on SSO2, so we can add that detail. So now it's section E on drawing SSO2, drawing SSO2, structural steel O2, and section E. Alright, our section mark is now added. Okay, this roof, you can see in a very short space of time we've managed to create an entire roof layout. We should copy across the title. Okay, got a title there for our drawing. We need to dimension it now. So let's say change that to our dimension, our dim layer. Start adding annotation, dimensions. We can go through, and as I said before, you can put on lines very quickly if you use this tool here, this continue function. Go through, give dimensions to the whole building, or you could use an array or something like that. Alright, and you'd add dimensions down the side, dimensions, etc. Then what you do is start adding sizes. Here we go, here's our girt sizes and purlin sizes, so they know what size occurs where. Let's move that a little bit further away from the building. So you can adjust those using the handles. Alright, and use that handle there. Move those away. So it tells them that in this end bay, the girts are cold formed lip channels, 175, 75, 22.5. The internal bays are 65, 22.5. The roofs, etc. So those sizes worked. Sometimes you'll have more sizes, sometimes you'll have less. It depends. With the new wind loading code, you generally have higher forces around the edges of your building, and then the first sort of few meters, depending on the size of the building. So you might have heavier purlins for the first few, or you have them just closer spaced together to compensate for that. Right, and now that takes us through a full layout. We've managed to create an almost entire layout in a very short space of time. All the details, drawings, etc. Section marks, we'd now go through it and annotate it, label all the roof bracing, label the vertical bracing, make sure you show it, label the circular hollow sections. You normally have a circular hollow section down the side here. That's for distributing or transferring the horizontal forces. You'll see it's that grey section there. So it transfers the load all the way down the side to wherever your brace bays are. And so yeah, you'd go through this, start editing, adding details, but within a very short space of time we have our details, and then we can keep going. Where we go after completing this roof layout, we can say that is now our completed roof layout. We might produce a holding down bolts drawing, an HD bolt. HD bolts are where do the bolts go? This is a very important drawing between especially your civil contractor or your building contractor, the guy is going to do the concrete, and then your steelwork contractor who will do the roof. Sometimes they're the same, sometimes they're different. It really depends on the job. So there you need to give them a detail of how do the bolts fit into each piece of concrete and where do the bolts go. So what you do, if I'm just going to go to our HD bolt laying, we stole these details from our earlier Tekla drawing from this job, but then you give them for each column, here's the UB3051F, I should say 102, sorry, 229. The reason to always check your drawings very thoroughly. 29, so you have all these different sizes that you give them a base plate size, what size plates on top, what size anchor bolts. You can get a lot of the details from the red book or the green book. The green book's got lots of details for connections. The red book's got all your typical HD bolt lengths and what length must be into the concrete and pocketed and all those sorts of things. So you can put all that in, put in HD bolt details. What's also useful is you put in a section through the HD bolt and try give them a frame. It's rather than giving them loose HD bolts, it's actually better to give them something that they can cast in. So maybe they weld plates between these 4 HD bolts, and it's less likely to get out of place when the concrete is poured. Or you can ask the steel contractor to supply a template which goes over the top of the concrete when they're casting. So all those are ways of helping the concrete contractor. Right, and over that we've now created our steel layout. We're going to continue then in our next lesson with further layouts, going into concrete layouts, foundation plans, etc. and continue with everything we've done. So hopefully you learned a lot this one. We've gone through hatching, we've gone through projection lines, gone through blocks, how you create a block, remember from inserting the block, how you edit the block with double clicking on it, creating arrays and the likes. In the next one we're going to start using layers more. We had a bit of more of an introduction to our layers, turning layers on and off and editing those. And then we're going to start getting towards the stage of creating drawing. All right, thank you very much.